when the visibility is poor, or if it's dark, you get caught out later in the day, or the feature you're trying to get to isn't in sight, but you still don't want to waste your time meandering around to try and find it, then a bearing is very useful. And quite simply, we start at just setting our map so that it's pointing in the right direction. So if each of you have a map in front of you, and you've good visibility, you can pick out, so say you're on the edge of a lake, you can turn the map to face the same way the lake is showing on the land. So that will then set your map in the right orientation. So it's turned the right direction. Another way to describe that would come in at the very beginning of a day of navigation, where you're imagining sitting in a helicopter looking down the bird's eye view of your map, and that if you were to draw a sketch of that, that would be orientated to the way you're looking at it. If then the helicopter banked left and changed the side of that map, the map doesn't move, you are moving around on the map. So the orientation on the land obviously stays the same. That can be quite a difficult thing to explain to people if you're bringing these skills back to your club. That can be a quite hard thing to get people to grasp. So a good technique for that is to get people, well, not currently, to hold a corner of the map each at socially distanced parameters, but you can get them to each take a corner of the map, and then between them as a group set the map. So, you know, pick some obvious features around you, and then they can shuffle and negotiate whichever is the right way for the map. But each person standing at each corner is facing a different way, but the map is still the same. So when you navigate, you orientate yourself around the map, which is set to the land, if that makes sense to people. So you probably already all know all of that anyway. So just to kind of set the scene for this session, I'm going to have a look at the different types of north that exist. There are 3 of them, to give you some foundations. I'm also going to look at it a little bit like that example there of how you might teach something. So you maybe already know all of this and want to refresh it, remind yourself. But thinking about teaching someone is a great way to practice it. If you can teach someone, then you can probably assume you understand it quite well. If you struggle to teach it, it'll tell you where your little weaknesses are, or your understanding is a bit shallow maybe, or not quite the way it really is in reality. So I'll look at the nodes. We'll look at taking guesstimate bearings. Oh yeah, go on, Anne.
Can I ask a question? I always figured that you orientate the map towards north.
That's exactly, yeah.
Yeah, right. I thought you were kind of saying you orientated towards the landscape.
It's the same thing, Anne.
Oh, is it?
It is. No, you're right. It is the same thing. I'm going to make a little note and I'll come back to it, because I think that's a brilliant question. So orientate to north and then orientate to landscape. Same thing. Okay, so that will remind me, Anne. Okay. So we're going to look at guesstimate bearings as well. So people often can take bearings even up to, say, when they're doing an assessment for leading people, and you ask them, what does that bearing mean? And they say, well, it means I go this direction, but they don't necessarily understand what they've actually measured. So a guesstimate bearing will help you understand. It's a bit like using the calculator without knowing what to expect roughly for your answer. So it's a good thing to get that guesstimate and that understanding there. And a hand bearing as well. So without a compass, a hand bearing. And map setting, which is what we kind of briefly started talking about. So then obviously I'm going to show you how to do all of that with a compass, how to walk on that bearing, and how to adjust bearings to suit what it is that you're doing with them. So if you want to measure a bearing from the map and then use it on the land, there's an adjustment that happens. So we'll talk about that. So again, I am making assumptions that some of you already know how to do all of that. So don't be worrying if I don't mention that adjustment until quite late on. It is coming. And equally, people may have never taken a bearing before, maybe never understood that there's different nodes. And so we'll kind of go from scratch all that way through. And if you already know a lot of that, just use it to check your understanding. Use it maybe as a way, right? If I'm teaching someone the next time, I can describe the fundamentals again for them through that. In terms of taking the map that you have to have a look at the different types of north, we've got 3 nodes. So on your map, you'll have a little diagram in the key. Describes all the symbols. On this section here is what I'm looking for. Might look a little bit different on your map, just depending on what series and what brand of map you have. But it's describing, you can see those 3 norths described there.
Yeah.
Yeah. So I'll just wait until I can see those, that I can see that they have that bit there found. Again, if you do want to turn on your videos, it's really useful for me because I can see you're there. But it's not essential. Yep. Great. Okay. So if you're not visible, just give me a thumbs up or something, and then I know not to wait. Yeah. Thanks. Thanks. Okay, so I'm just going to read this little bit off there. So just on the map, it's got a picture of these 3 arrows. Okay, so I'm going to take, if you think about it, and apologies for those that already know all of this, don't want to patronize you. Just when you think of it, the map has grid lines on it. It's like your textbook kind of north, south, straight up, straight down, east, west, straight across, horizontal. But obviously our Earth is not a box. It's not straight, it's not flat that way. So a grid line, it's like a model of an ideal square, straight up, straight down. So therefore the grid line, the grid north is straight up. But in reality, on the land, the true north, the North Pole, is not straight up, it's a little bit off the side. And the magnetic north, magnetism is a force, it moves inconsistently, but it consistently moves. So it's a constant unconstant, which is where I think people struggle and why we have to manipulate our bearings once we've taken this textbook grid, we've measured off the map, say we wanted to travel straight up the map, which is due north, we'd expect a bearing of 0 degrees because it's straight up, and if we were turning around and going back, we'd expect a bearing of 180 degrees heading due south again. So in answer to some of your question, Anne, north is straight up on all maps unless they say otherwise. So when you are setting that map, you are lining that north line with the north and also with the landscape. It should be the same, give or take a fraction. So on your map, again, and this can happen when you're in complex terrain, the writing is always the right way up. These lines here go up to north and down to south. But sometimes when you're in quite open country with no real man-made features, just contours, sometimes you can lose track of which way up it is. So the writing is always the right way up. That means then north is up from there. So this isn't a particularly, there we go. So if you find a section there, there's nearly always writing somewhere that will tell you which way up it is. Some of the more remote parts of Donegal and Kerry or Galway, Scotland, you'll find where there's less writing, so you might have to look a bit further. So if you're pointing straight up on the map and wanting to travel, sorry, if you got the map lined up that way and you wanting to travel straight up, you'll expect a bearing, you do a guesstimate bearing of around 0 degrees. So on your own map, I want you to have a look, pick a point, a mountain top or something, and then pick something off to the right and slightly south and get a guesstimate. What bearing roughly are you going to get in that quarter? And again, there's chatter, there's verbal, you can say it. Okay, so once you've got some answers, either type them into the chat or throw them out verbally. So this is something you can do just by eye. It doesn't need to be a compass. It can just be by eye, just from here to there. Roughly, what are you getting?
140.
140, yeah. Are you sure? Are you not sure, Anne?
Is it just the north line you're looking for, or both?
Okay, sorry, I didn't explain it very well. So if you are, just pick a point on here. So
If it's both at 177,945.
okay, I think what you just measured there is a grid reference.
Yeah.
Be right.
Sorry.
So no, you're fine. You're absolutely fine. So that's to locate a point on the map, and you sound like you've done it perfectly fine. What we're looking to do for this instance is to do a guesstimate bearing. So if you've picked a point on the map, say on this one here, I've got Lugalore, and I want to head somewhere roughly southwest of southeast of Lugalore, just pick another point and head that direction. What rough bearing is that going to be to travel southeasterly?
Southeast. Yeah. 15. What was I saying?
I think you're doing a grid reference again.
Oh yeah, sorry. I'm not trying to just pick a point.
Yeah, so I'll give you an example. My apologies. So if I'm standing on Lugalore,
Yeah.
so on the screen there, and I want to head down to the south end of Loch Tay.
Okay.
So if I was joining those two dots between the top of Lugalore and where the river leaves Loch Tay in the south,
Okay. Yeah.
what direction is that? So
Oh,
yep, I didn't explain myself clear enough, obviously. You found the point fine, you're good at grid references. We're looking for just the direction. So
the
in
direction
degrees.
the direction is east, southeast.
Southeast. So if you were to translate that direction of southeast into a bearing, a number of degrees, would you be able to do that?
Well, it's one on the map. 15, 16. That's what I don't think I know what you mean then.
No, I don't think you know what I mean either.
No.
That's fine. That's fine. No, that's grand. So I'll go back
I know where you
bit.
are. I can
Yeah.
see where you are on Lugalore, and
Yeah.
I see the direction you're going.
Okay, so what I've missed here, so again, for teaching folk, north straight up is 0 degrees.
Yeah.
Okay, so if I then move around around the other directions there, Anne, around this line across, that will be roughly 90 degrees straight across. So
Yeah.
and if I then head due south, that's going to be 180 degrees.
Yeah.
So what we're looking for the answer to be is somewhere between due south and due east.
Yeah.
So the answer is going to be somewhere between 90 degrees and 180 degrees from the top of Lugalore to the bottom of the lake where the stream joins. So are the rest of you getting that? I just know where I can see Anna. I just have no way of knowing if the rest of you are or not. Yep, cool. Thanks, Abraham. Great. Thank you. Yeah, I see you. Yeah, thank you. Thanks, Gabriel. Okay. Are you getting that, Anne?
I don't know what I have to get. The size of the angle.
Yes, exactly.
And how do I measure the angle?
You can do it by eye, or we will be doing it later using the compass
Oh
to
yeah,
measure
from
it.
that. Well, what kind of an angle? If I had
Yeah,
the
yeah.
compass should be able to tell me.
Yeah, a compass can do it really accurately, and by eye, you can do a guesstimate.
So my eye. Well, that's 90 degrees. Oh, I'm useless at maths.
At maths or maths?
At geometry.
Okay.
I haven't a clue about angles. I know a 90-degree angle, but I don't know any other ones.
Okay, so, but that's fine. So if you know 90,
Yeah.
if you were traveling halfway between 0 and 90, then the angle is
45.
going to be about 45. Exactly.
Yeah.
So that's really all I'm looking for you to do.
Okay.
Nobody really, well, very few people would be able to know exactly how many degrees an angle is. They'd have
Yeah.
a ballpark guess. Is it
Okay.
90? Is it, I can't get my thumb to go straight down. Is it 180? Or is it roughly halfway? Do you know what I mean? That's all I'm expecting you to do, and you're being hard on yourself. So all in this situation is from north down, we were measuring something roughly that angle, somewhere between this and this. So the first quarter is 90,
Yeah.
and then another bit on, so say 45 degrees. I've not really looked at the exact angle that it is, but it's going to be somewhere halfway between 90 and 180, thereabouts, maybe a bit less. Okay, so you're not being dim, I assure you. You just didn't understand the question, I promise you. So that's roughly what a guesstimate bearing is. So if we were traveling back the way, you'd expect the answer to be the converse, the opposite. So from the lake back up to Lugalaw, it's in the opposite direction. So it's 180 degrees more now because you've turned around and gone back. So it will sit somewhere between, in the last 270 to 360 degrees of 0 quarter. So just here on this diagram, is what I've been describing. So due north is 0 degrees or 360. It's your circle. Okay.
Yeah.
Try and put memories of school and maths classes out of your head. The maths side of mountains is generally quite practical because you're using it. There's a purpose to it. Where a lot of what you might have done in school, it's quite easy to lose the purpose of it potentially. And if you don't get it on top of that, that can just make it a bit quite like you just draw a blank on it. So all we're doing here using this is the knowledge that our map grid lines go straight up to north, straight down to south, and then out to the east and to the west, and that this quarter is 90 degrees, that quarter has 90 degrees, and so on, and all together it makes up the full 360 degrees of your circle. So all we are measuring is the angle of any route from north to wherever we're going. If we're going due south, then it's 180 degrees of an angle. If we're going to go from here to here, that's going to be from north a 90-degree angle out to where we're going, or 270. I can't read backwards from here. So if you want to try a couple more yourself, you've all different maps. So pick a hill, a point, and then pick another point and do a guesstimate bearing from A to B. If any of you want me to check any, just give me a shout what map you're on and what point, and I can double check things for you. Just pick a point and pick another place you want to get to, and just give me an idea of the bearing roughly, just by eye, to get to it. Thanks, Abraham. Good. Okay, so there's a little one here I can do it's just a rough one that we can all do together. I'm getting the impression most people are getting this, but I'm not 100% sure because I can't see some. I'm going to put up a diagram of a grid I've drawn. I've put 3 peaks on it, A, B, and C. So all we'll do is I'll ask you roughly what's the bearing from A to B, and so on. You can just call out your answers or type them into the chat. It doesn't matter. So you see on this diagram here, so this is A. I don't know what view you've got, but you can put me onto the speaker view so you can just see my screen. Yeah, so it's big. So from A to B, and tell me what bearing that's going to be. So from north around, what rough bearing is that one going to be?
$60.
60 degrees. That working out the same for everyone, roughly around 60 degrees? So this is the line we're drawing. So from north. Okay, so it's not 0, it's not 90, somewhere in between. Would it be about, sorry?
About 45?
About 45 degrees?
Or a bit less.
A
40.
bit less? 40, great. Okay. So this is it's just a guesstimate.
Yeah.
And I'd say none of you are exactly right, but you're all in the ballpark. And that's why we use a device to measure it if we need to be accurate. So I'll just do 1 or 2 more just to be sure everyone's happy out with that. So we can go from B to C this time. So from B to C, just call out your numbers.
180.
180.
180, yeah. It might be a slight bit off one way or the other, but yeah, that's the ballpark what we're in. And then from A to C, so from A
90.
to C, 90. 90?
Yeah.
Yeah.
Bit more.
A bit more. We're getting precise now, that's good. And then last one from, read the letters, from C to A.
270.
130.
130?
No, more. It's more than 180. Anyway.
Exactly, yeah.
About say 220 or 210.
Okay, so this way was about what, 90-ish?
Yeah.
So
270.
really,
Oh no, this if going directly. Oh yeah, that's 90. Sorry.
yeah.
And then so about 120.
Okay, it's going to be about 270, and it's not, I think, because you don't understand it. I think
180 was straight down.
yeah. So you
And
keep
then-
going another 90 or so.
Yeah.
That's just the addition bit that's tricky.
Yeah.
That's all. Okay. So I think that's fine if all you need is a rough answer. It's the same, if you're measuring distance or any of those things, you can say, well, it's about a box, so that's about a kilometer. But if you really need to be exact and precise, then generally you'll take out a ruler or protractor or something to measure whatever it is you're trying to measure. So for distance, a ruler is what you'll need, and for bearings, a protractor is what you need. In school, the protractor is, your half moon, your half circle, but on a compass, our protractor is the full circle.
Oh yeah.
Yeah. So all we're really doing is taking what we've done by eye and putting a bit of definition and sharpness on it. We've made it accurate because it's definitely going to be exactly this many degrees from north to wherever we're traveling to. Okay. So keeping with our guesstimates for the minute, I know you're dying to get onto the device, but keeping with the guesstimate, if we've got reasonable visibility and we're standing on this point here, and we've got enough features around us to line up these 2 peaks so we can see them, and we want to head off, they all look very similar, they're not too far apart, a momentary lapse of concentration. You could easily walk to the wrong one. You know, we all do that sometimes. Well, I don't, I never do, but other people might. And so if if you're wanting to double check, you could get your map lined up and then just put your hand, if you've got your map set, say, right, it's over there, or you know, it's that one over there. That's a hand bearing. So long as your map is set, you're using your hand to decide which way to go. And this can be a really useful thing when, say, you can't be bothered to take your compass out and measure it and faff around, but also say you're on a ridge and there's 2 ways off, and they both are doing the same thing in terms of features. They're both a ridge and they're heading off and they're going downhill, maybe onto a spur or something. But it's like, is it that one or is it this one? So that direction thing, the same on a bend in a river, a bend in a track. You can have a look and see what way it's pointing. You don't necessarily need to take your compass out to prove it, because, like, you know, it's very different angle to there to there. So you can say, right, it's not that one, it's this one. I'm going to head off that direction rather than this. But if then your visibility is curtailed and you can't see it because there's a ridge in the way, or the mist is in the way, or it's dark, then you can measure what you can't see on the map and transfer that information onto the land. And then the compass can tell you where that feature is that you would be able to see if it were in view, if it were visible. Okay? It's a really important connection to make, I think, really important. So all the compass is doing is taking your guess and making it accurate. The guess is really important because then when you get your answer, you know it's in the ballpark. If you've measured it that way instead of this way, the alarm bell will ring because you're expecting a 90, not a 270 kind of answer. And if you get the opposite, you think, what have I done wrong? It's not in the right ballpark. So if you want to spend time on this as well, there is a video, a presentation on our website about taking bearings, where it's a bit more classroom kind of textbook. You do this, then you do that, and then you do the other, and this is your answer, and then you adjust it. And there's a video on walking on a bearing as well, which will be really useful after this as well. We'll talk about it here today, but you get to see it on the hill, and it's me describing it, so it'll be the same language that you'll have heard today. So if we want to take a bearing, we mentioned that there were more than one north. There were 3 norths. We talked about grid north, which is the one we've been kind of hammering away at here. We talked about true north, North Pole, which is very interesting, but as a navigator, it's not something that's of use to us. And we talked then about magnetic north, the force, and it's the force that draws the needle, the magnetic needle in your compass, towards it. So we can use the north on our map, we can use the needle in our compass north and bring the 2 together. And that then will help us direct ourselves on the mountains. So what we've just been describing is grid north. So we'll have a look at how to measure that now accurately with your compass. And then we'll move on and look at how that and magnetic north line up. So if you want to pick your maps, and I can set you a few tasks. So I believe we have 2 people in the Mourns on Mourn maps. So I'm going to just give a couple of points for me to be on a Mourn map, maybe just one. I'll pick bottom left of every map that I'm using, just it's easier for me to track them all down. So bottom left on the 1 to 25 Mourn map, that area. So we've got, and I'm going to pick 2 points as well. If you're teaching compass bearings, use points rather than areas so that everybody can be as accurate as they can be. So from Sleeve Martin, it's got a triangle, a triangulation point on the top with the dot in the center of that, to Sleeve Mean, it's south of it. Okay, so what I'm going to do now is quickly just talk through, because I know as soon as I give you these tasks, everyone will set off and start doing it and not listen so much. But so what I'm going to do now, I'll describe for this particular one how I go about taking that bearing. So I've picked 2 definite points on my map. I then take my compass and just, there's a bubble in this compass, not a good thing, but just they shouldn't be there. I'm going to take this compass and I'm going to use, you see this long line here? It's got no writing on it and it's a long clear line, so it gives you good visibility of the features underneath that you're trying to join together. And I'm going to put this line along from my A, my starting point, to my B, where I want to go. And there's an arrow here on your compass. So this is the direction of travel. So from my A to my B, this way, this direction. I'm going to put that on those 2 dots, the top of the mountain and the peak I want to travel to. And then I'm going to turn this dial and line. If you just keep looking there at the screen, I'm going to turn this dial so that this arrow that I can move, my protractor, points straight up north on the north grid lines, straight up to the north. So whatever way this is lined up, I'm going to turn my arrow so that it lines up with the grid lines, pointing straight up the map. That makes sense?
Mm-hmm.
Yeah. And once I've done that, then I can measure top center here on the dial. It'll give me a number of the bearing. Okay, so I'll just repeat that one more time and then I'll let you away and I'll set different places for people. So my A to my B on the map, direction of travel from where I am to where I want to go. Turn my dial to line it up, this here, parallel to those grid lines, pointing straight up the map to north. And then I'm going to read what I get off the top center. So you're almost all of you are on mute at the moment. If you want to take it off mute, you're welcome to. It's okay, you don't have to. It's okay. So I'm going to measure Slieve Martin to Slieve Mean. It's south of, so I'm expecting an answer somewhere around 180, give or take a bit. It's okay, Anna. So those of you that are on the Mourne map, there's the tops. Sometimes the points can be quite hard to see. And don't worry about the route, whether it's putting you over a cliff or any of that. Just do as the crow flies, straight. Okay, so that's two of you, I think, have a task there. We have a sheet 38 somebody is on, I think. See what I've got. Is it sheet 38 for someone? Connemara?
I'm on the activity map.
What sheet number is that one?
This one doesn't say, it's just an activity. 1 to 25.
Or Connemara?
Mourns.
Oh, right, okay. Do you have those 2 features on that map? Slieve Martin, Slieve Mean, near Rostrevor.
Near Rostrevor?
Yeah, it's just east of Rostrevor. Okay, and who said they were in Connemara?
No, I have the Wicklow map, so I can do.
Okay, so sheet 56 then for those that are in Wicklow.
Yeah, I have 56.
Okay. So again, I'm going to pick bottom left of the map. And if
Yeah,
you
I've got them
say,
here.
yeah, brilliant. So if you use those 2 points then. So on sheet 56, we've got in the bottom left corner, we have a mountain called Lowbourne. It's near to Donard, the town, village, Donard.
Yeah.
Yep. So if you go from Lowbourne to the Sugarloaf, just to the bottom, southwest of it.
Oh, yeah.
Yeah. Okay. Okay, any other maps there, guys? What other maps do we have there, guys?
I have a sheet 26, but I also have a Harvey's 140 of the McGillicuddy rigs.
Okay, I got that one, yep. So on the Harveys, again, if we go bottom left of the map, Mulliganatton. Again, just be careful where the dot is. There's a triangulation point on Mulliganatton and a dot in the center of it to the kind of the northeast 594.
Yeah.
Okay. That's great, Abraham. Thanks. I just saw the chats there. I hadn't seen them. So if you want to either tell me your answers or put them up in the chat, I can just read out the answers if you're finished.
I got 176. That was the Mourne map. Sleeve Martin to Sleeve Mean.
Okay.
Same as that, so.
I got 76 on the McGillicuddy rigs.
I'm getting, for the sleeve mat, I'm getting 181. I'll just double check it. Yeah, just 171, almost 2. Sorry, 81. Sorry, 181. 2ish. Maybe just check that the dots are bang over the dots. The 741, the dot is above it. Again, and then, sorry, what was the second one? You got 7 for Mulliganatton, was it? 70?
76.
76. I'll just double check that one as well. Yeah, perfect. Yeah.
Lowbourne to the Sugarloaf.
Yep.
220.
Perfect. Great.
Oh, good.
Don't say so surprised. Anna, if you're getting the same answer again, just give me a shout, because there'll be something. Yeah.
Yeah, I still get the same answer. Is that there's like a wee, do you know, contour? There's a wee circle of a contour line. There's a wee dot in the middle of it for Sleeve Mean.
I don't see a ring contour. I think that's what you're describing, isn't it?
Yeah.
Oh, actually, I do see something. What is it? Oh, yes. Yeah, because there's a circle. Sorry, it's very faint, isn't it? The wall crosses just through the dot, through the same place. Yeah, I'll just double check it again, because usually, and it's a good kind of comment, because usually if you're a degree or 2 out, it's just down to getting it exactly over the points. But I think, was yours about 4 degrees between 180? Yeah.
It was 176.
Yeah.
Still getting 176 using that dot in the contour circle.
Yeah. And the dot in the can. The dot in the yeah, I'll just double check it again. That's quite a big range for something that's 2 points. You know, I'm still getting 182. We must be doing something different, because I don't doubt you can take a bearing. I'm just trying to work out what it is.
I don't know.
So that black line on the compass, I'll just do a bit of troubleshooting because there's bound to be something there. So this black line here, you should be able to see straight down that it's directly over the center.
Yeah,
The
it's
short-
a silver compass I have too, so
Yeah, no, I mean, any compass should be accurate, you know. The other thing that you can check, again, it's good for everyone. So you see these lines here when you're lining up your north. If you're able to have it so that one of these lines sits directly over a grid line, and then check at the bottom and the top of the grid line that it's exactly parallel.
yeah, I was doing that.
Yeah, no, that's what I'm saying. You look like you know what you're doing. I didn't doubt that you could take a bearing, so I don't want to undo what you could do. So then the other thing then is to check that people have the same points that you're talking about, and it sounds like you do. So the dot in the center of the triangle and the dot, we've described it fairly clearly. You've got exactly the same dot. I'm trying to think. It's not moving when you move the north around. No. So sometimes your dial moves the compass. You have to press it hard on the map.
Yeah.
Let me think what else.
No.
And the other possible rare thing that happens sometimes, I've got a newer compass here. Just sometimes you see how there's a bright bit here. It actually is luminous in the dark.
Mm-hmm.
Sometimes, and some of the compasses they made, this started to move
Right.
and started to shift. So it kind of throws. I doubt that's what's happening in your case, but that can sometimes, and it shifts around here, and you're suddenly looking at the wrong place for your bearing. I don't know why we're not getting the same answer.
I don't know if you can see, well, it's just moved.
It's really hard to put up on screen. I'll try and see if I can.
Kind of like that. I can see it. I'm not sure if you can.
Okay, so just keep talking, because anytime any other noise from anyone else comes, you disappear. So pop it back up again. I've got you on full screen now, so I should have the best chance.
Let's see. Where was this? I saw it's just moved again, so
Yeah.
It's hard to hold it.
I know. So this is another useful teaching point. Fold your map as small as you can get it, so you can stick your thumb around.
Oops.
Just lift it up a little bit higher.
Can you see that?
Yeah. No, I don't doubt you're doing it exactly right. I just can't. I'd need to be stood over your shoulder looking.
Yeah.
Sorry.
Understand.
It's frustrating, which is why we don't teach our courses like this all the time. Okay, so, but that has been very beneficial in terms of a troubleshooting perspective, even though we've not got down to the reason why. What we'll do is we'll do a couple more and see
if that
there'll be
works.
some reason, there'll be something there. There's no fold in the map or anything.
No.
It's not wrinkled.
No.
Sometimes that can, it's not even on a fold, it's near one, but not on one.
Yeah.
And what year is your map? But again, it's very unlikely that they've moved the spot out or moved the trig point.
You weren't adding on a magnetic variation, sure you weren't, no.
No, because I wondered about you, but that would be the other way around.
Yeah.
You know, yeah. Okay, we'll park it for a minute, and we'll try a few more, and we will get to the bottom, I'm sure, of what it is. So on the same map, if we pick Slieve Meal, it's north again, just north of the Ross Trevor Forest.
Yes.
Slieve Meal to 0.432. Okay, and those then on the Wicklow map. If you go from Corrybracks, which is just north of Lowbourne and Sugarloaf, the Corrybracks to Church Mountain.
Okay.
And then those on the Kerry map. Excuse me. If the 0.594 that we last used, southish to 0.522.
For Sleep Meal to the 432, I got 60.
Hey, I know you know how to do it. I just not worked out what's going on. Sorry, who? Someone else said.
Yeah, 60 as well.
Perfect. Great.
I was scared to tell you that in case it was wrong again.
I know, it's so frustrating and really frustrating for the person when we don't get to the why bit, because you're doing everything and you're like all the checks and balances are all matching up, all the troubleshooting got us nowhere, and so on. And just actually what did you get? I didn't see who said they also got 60 there. Which was that, Vincent or Gabriel?
Yeah, that Vincent here. I'm on the same map. I got 60 also.
What did you get for the first one?
178.
So, in between.
In between.
So, okay, so.
But and can I actually see one question on that? I'm taking on, you give a sleeve margin. I'm taking from the center of the trig point, not the dots, just slightly higher and to the right. So is it always from the trig point you take it?
Well, that's where I was describing. Do you know what I mean? So,
right.
I'm not sure that dot is in the
the
center.
trig point's going to be the peak. Yeah.
Yeah, like, well, generally.
I was just wondering if that's why we were all slightly different.
See, the dot in my trig point is in the center of the trig point, the high point.
Yeah, it's in the center of mine.
There's something else in there.
It's obviously not a good example, and maybe I shouldn't use that one again. But yeah, like, I mean, it often when you're doing this on the hill and you give it, a task to your group of 4 or 6 people, you will get a slight range of answers, and it usually boils down to the accuracy, or they thought that you meant somewhere else, or whatever. So between us, we've got, yours was 176, 178, and 181. There's quite a range there between us. It's all a variation on a theme. But there's still this, it'll boil down, I would imagine, to where we're actually measuring from, and whether we've got our line over the center of the dot or slightly left at one end, or, I would imagine. It is a very short distance really for a bearing, not that long a bearing. So any slight bit to one side or the other is going to change the outcome. Okay, so I have to let it go.
The one I did then was Corrybracks to Church Mountain.
Yeah.
300?
Yeah, I got 299. Perfectly.
Okay.
Bang on. Yeah, dead on. Great.
Kerry map, I got 148.
For which one, sorry?
The Kerry map, 594 to 522.
Okay, I got 159. I'm just going to double check. We've measured different places. And so I'm just going to double check mine. You want to do the same? Oh, I just wrote down the wrong number. It is 149. I wrote down 159. It's still set.
Okay.
Yep, no worries.
Yep, perfect.
Okay, so do you want to do another one? And I'm asking particularly for Anna, just to reinstate your confidence. We'll do one more round, guys, and we hopefully, I think people are getting it right and are understanding it. So from the Kerry Max, it's the first on my table here. If we go from 522 to 455, you're kind of moving along that ridge. And then on the Mourne map, if we go from, there's just up and left a little bit of Ross Trevor Forest, Lecken Moor to Lecken Beg. Table Mountain to Connaballa.
I got 156 this time.
I was about 158.
And I'm trying to just find it. 4, 12, 3, 2. Yeah, no, just a minute. Okay. Sorry, which one were you on there? I'm losing the run of them here. Wait, 1, 5. The Moan one.
Yeah. About 156, 157.
Yeah, spot on. It's like waiting for the lottery, isn't it? I measured them all, but I didn't write the answer down. Yeah, so you were both. I think I got just a shave over 156, but like on the line.
Yeah.
The other thing I'd thought maybe is you're aware that each blip is 2 degrees.
You make me some lunch.
Yes.
Yeah, yeah. Sorry, no. Well, I'll stop trying now. We'll work it out. Okay, and then so for the other 2 maps, the Kerry and the Wicklow.
I got 128 for the Kerry map.
I got 127. Yeah, again, spot on.
And 90 for Table Mountain to Connemara.
I got 92. So yeah, it's in the ballpark. Like a degree either side of each other. Yeah, like it's not a huge difference. It really just boils down to exactly where the lines are joined. Yeah, like if really to fine tune that, if you, like I said before, if you just check that the parallel is the same parallel at the top as the bottom where it sits next to it.
Yeah, that's the hard thing to see.
Exactly.
Yeah.
Like there's a magnifying glass, but it's not there for taking bearings. It's just there to look at stuff, I suppose. You're using it. Some people blow their maps up bigger into a bigger scale. You know, to kind of counteract the age of our eyesight. So as long as it's still an accurate scale, you could make a 1 to 50, a 1 to 25,000 by, you know, photocopying it on a zooming in.
Exactly. Yeah.
So a lot of folk would do that. Yeah. Just
Hi,
need
Anne,
to.
could I ask one question, please?
Yeah.
Sorry, I'm going to have to leave the call shortly here, but can I ask, you mentioned that you've got other videos in the series. How can we access those?
So on the Mountaineering Ireland website, on the training pages, you will see, when you click training, you'll see a tab on the left called skills videos.
Brilliant.
And there's a video on walking on a bearing and taking a bearing. There's also presentations as well, training downloads.
Okay, that's great. Thank you for
I'll
that.
send a follow-up email with all the bits in that anyway. So, yeah, so they'll all be there listed for you.
Yeah.
And just give me a shout, Vincent. You're welcome. We didn't get as far through for you. Yeah.
Right.
Okay, so I think the bearing side is good. I think people are getting their answers. Was there one from Kerry? Did we get the Kerry answer? Is that the fella that's just gone?
No, he was north, I think.
Yeah.
He was in the orange map with me.
Okay. People keep moving position on the screen, so you can't, it's not like a classroom where you've got them in the spots. Okay. So if someone is out there waiting to give an answer for Kerry, just give me a shout and I can check. Or Wicklow, I think we've got all of those now, the Wicklow one. Yeah, I think we did everyone. Okay, so that's our bearing that we can measure it off the map to use. So then if you want to translate that to use it on the land, so then you'll need to adjust it. There's a variation. So the grid bearing is like your textbook, straight grid, where the earth is round, and I'm simplifying that, but to try and get your head around it if you're not already aware of it, that the magnetic variation is important. The magnetism moves, it's a force on the earth and it moves. So if you don't adjust for that, then your bearing will become over time less and less accurate, or more and more accurate as it tends towards there being no variation. So at the moment, every year the angle changes slightly, and we have to add a little bit to the bearing that we take off our map. So every year, if a bearing is made up, a degree is made up of 60 minutes, a bit like minutes and seconds in time. Every year, 10 seconds changes. So in a 6-year period, it will be a degree of a change that you need to adjust your grid bearing by. So if you look back in that place where we first went to find about the 3 nodes, you'll see in either right next to it or right below it where it describes magnetic variation for your map, for your area, because it's different depending on where you are. It differs. So just above in this section here, it'll describe what I'm talking about. So above the 3 nodes, just route that out off your map, and I'll read out the relevant bits for you. It might be in a slightly different place on the Reeks map, but it should be there. Oh yeah, so on the Harvey's map, they talk a lot about GPS and using GPS to navigate by, which a lot of Harvey's maps users would use. It's like it's a different, slightly different audience maybe that it's directing its map towards. And it's a newer map, so they would have been more considerate, I suppose, at that point of including the technology that was available for their users. But on the Harvey's map,
Yeah.
there's a section here, and some map makers describe it in a more user-friendly manner than others. Some are more kind of scientific about it, or a bit more classroomy about it, where at the moment the variation each year is about 10 minutes. Which is quite tangible. You can understand that. So this year it'll be 10 minutes. Next year there'll be another 10 minutes change, and then the following year another 10 minutes. So you can kind of see how it evolves. That 10 minutes is a changing number, but at the moment it's 10. It was 9.8, and it will become 10.1 or 2. But if you think how small and insignificant potentially a second is, it's not a huge difference, and we can't measure seconds on our compass, only degrees. So I'm not dissing the importance of those tiny numbers, but it's around 10 at the moment, and in some places is exactly 10 per year. So in every 6-year period, it changes by 1 degree. So I'll go back now and describe how we apply that bit of knowledge to our grid bearing and what we have to do. There's a general saying, so we've all been measuring grid bearings, and we want then to use them on the land. So we'll say from grid to land, you add the variation, that little difference that we've been describing. So it's going to increase the number. So say you've got 120 degrees, you're going to be adding a little bit to that depending on what your map is telling you that little bit is. So to do that, you need 2 or 3 bits of information from your map. So in this section, it will tell you what year is the starting point. It'll tell you what year that map is made, and it will give you your starting point. So if you've got a very modern map and it's made, only a year or 2 ago, you don't have to do a lot to adjust. But if you've got a map from 20 years ago, you may need to do 20 years worth of adjusting. So in that box, it says on this map, it's 2005. So it's quite an old map that I'm using. But for yourselves, I want you to find the year that's written in there and just make a note of it. Once you've found that year, just tot up how many years have passed. So mine's 2005, we're now in 2020, so that's 15 years. Hopefully your maps are a bit more recent. And then, I know people have, the second bit of information that's of interest to you, just after it says the year, it should say annual decrease. On this map I'm looking at, it says 10 minutes. So again, I don't know if you can see. So I've got the year, and then it says annual decrease 10 minutes. And the minutes is that little, the symbol, it's like an apostrophe, as opposed to the little circle you'd get for degree. Okay, and it's saying that the annual decrease is 10 minutes. So I would make a note of that as well. Annual decrease is 10 minutes. It may be 9.8 or 10.1 on yours, or somewhere around that, but it will sit in the ballpark of 10 minutes. And then the last bit of information, it says in the same sentence as the year, at the center of this map, magnetic north is, and for my map, it says 5 degrees and 36 minutes. You need to jot that down as well. It should be in the same sentence.
Oh yeah, 5. Yeah.
Yep.
Yeah.
So it can vary depending on where you are. So don't worry if you're getting at the center of my map, it's 4 degrees and 2 minutes. You know, yeah. So you should have the year of your map, the number of years that have passed since, the annual decrease, and then the bearing at that point, the variation at that point, which will be around 5 degrees or 4 degrees something, or 3 degrees something, depending on where you are. So it's a maths then, bit of maths. So for every year, 10 minutes will be lost. So I have 15 years, that's nice easy maths for me. 15 times 10 is 150 minutes. And I'm just conscious of not trying to lose anyone. So if I have 10 years at 10 minutes, I've got 150 minutes. And like with minutes and seconds, 60 minutes equals an hour. So if in this case, 60 minutes equals a degree. So if I have 150, that's 2 lots of 60 and then 30 left over. Am I losing you? I'm really sorry. I'm really sorry. It's so frustrating. It's like I kind of know, because it's, I think a lot of people are good at math because they can do the mental visual picture of it. And a lot of people struggle because they can't see it. They need it written down in front of them to see. And it's just different ways people operate. So I have 100. I've just written down, where is it there? I've got, where is it? So that was my year, 2005.
Okay.
Now 15 years have passed.
Okay.
And every year it's a 10-minute decrease. So in 15 years, every year 10 minutes has decreased. So after 6 years, that's 1 degree. After 12 years, that's 2 degrees. And after another 3 more years to make 15, that's 2.5 degrees.
Yeah.
Is that making sense? Is that a bit more tangible? Yeah. Okay, so that will leave me with a 2.5 degree decrease. Okay, and for those of you that don't do it that way, I will come back to you, so don't worry. So that's 2.5 degrees, or 2 degrees and 30 minutes. So from my starting point of 5, I can't do this backwards, 536.
Yeah.
I need to take off 2.5 degrees. So.
Oh, you have to take that off.
Yeah, yeah.
Okay.
So if we were in the year 2005, that's what I would add to my bearing that I've taken. But because time's passed and it's decreased further, it's now 5 degrees 36, 4 degrees 36, 3 degrees 36, 3 degrees and 6. I've taken them off. So now, 15 years later, I would add 3 degrees, and we can't really do the 6 minutes. It's just, we can't measure that. So it would be now a variation of 3 degrees.
Okay.
Yeah? And that's just the maths, just what I've said there.
Yeah.
Yeah. So it's a little bit like trying to do addition with time and multiplication with time and seconds. So Abraham, the rest you don't need to just carry on if you're Abraham. Thanks for your thing there. So you've got 9 minutes at 11 years. It's got 99 minutes.
Yep.
So 60 would be 1 degree, leaving 39 minutes over. And then I don't know what your starting point on the Moore map is. I'll just check. It's probably the same year because they've not made that many new. Or you can let me know. So your starting point was 136.
Yeah, 137 it's saying here. Yeah.
Okay, yeah, that would, and they do make correction. If you've got a newer map, they'll correct past slight inaccuracies. My map is from 1996. But not a lot of inaccuracy there. You know, 1 minute. Not a lot. So you've got a minute. So you'd be nearly 0 then. That'd be right. 99, 1 minute 39.
Yeah, it's not far off it.
136. Yeah, you would actually be 0 because you can't. It would be 0 degrees and 0.03 minutes or 0.1 minute. And you can't measure that on your compass. So your grid bearing is your magnetic bearing at the moment.
Okay. So I'm going with the grid lines basically.
Yeah. In 3 years, it'll tip to just over half a degree. So you can then start to add a degree.
Is that the Mourne?
Yeah.
Is that the Mourne map, Jane?
Yeah.
Right. I have a 2009 Mourne map.
Okay.
You see that 137? It says at the centre of this map, true north is 1 degrees 37 minutes west of grid north. But sure, that's not the one we use. Is it the next one? At the centre of this map, magnetic north is 6 degrees 18 minutes.
Sorry, you're right. Yeah, no, this is just written in a different order on there. Yeah. Yeah, sorry, it's written in a different.
Yeah.
We're looking at different formatted text. Sorry, yeah. So magnetic north was 8.4 west of grid in 1996.
Right.
I was reading the true north one.
Yeah, that's okay. I just wanted to make sure I was getting it right.
No, you're right. So does that make sense, Abraham?
Say that again.
We've gone off back to the maths again. The description there that you read out is true north. What you need is magnetic north. It's just that the text is in a different order.
Oh yes, 6 degrees and 18 seconds.
Yeah. So the maths you'd done was correct, but the data that you'd used to do the maths wasn't. You pulled
Yeah.
the wrong bits. Yeah. Okay, I'll leave you to redo the math there, Abraham. So how are you getting on, Anne?
Well, I was looking at two of them. I was looking at my Harvey's 2015, and
Okay.
they just tell you there, magnetic north is 4.5 degrees west of grid north in 2015, decreasing by 1 degree in 6 years.
Yeah.
So you can kind of just work it out.
Doing any of the background?
Yeah, and
Yeah.
then the 45 one that I was using, the Ordinary Discover series or OSI, that was 12 years, 2012, so 8 years. And the magnetic north at that stage was 4 degrees 23 west. So 8 years with the 10-minute decrease, it'll be about 1 degree and 20. So I just took, say, 120 from 4.
Yeah.
23. So
Yeah.
3 degrees.
Yeah.
Yeah.
Who said you did anything wrong with your maths?
I take shortcuts.
You have to move on. Yeah, you're too fast for your own good. There's nothing wrong with your maths at all.
So now, say my bearing, Table Mountain to Cannavalla is 90 degrees. So do I add the 3 degrees onto that?
Yeah.
I do. It's a plus.
Yeah. So grid
Like,
from
west,
grid.
when they say west there, I was wondering why it was the 4 degrees west. They say 4.5 degrees west. So
Yeah.
I thought maybe you'd have to adjust it to the west.
No. So if you look again at this,
add it on.
if you look at this here now, you've got your grid which is straight up.
Yeah.
And the magnetic variation sits to the west of grid.
Oh yeah.
You see what I mean? Am I looking at the right one?
Yeah.
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 And if you like, true north sits to the east of it.
Yeah.
So that's what that's referencing.
Yeah. Exactly. Yeah.
And because it's changing and decreasing and moving, and eventually, like that wrong example that we did would move you back. It would be we're tending towards 0, and in theory, it may continue past.
Oh
so,
yeah.
So where we've said from grid to land, and that may not stand forever.
Yeah.
If it keeps doing what it's doing in the direction that it's doing it, eventually it might be the opposite way around. So I'm always cautious about using simplifications without the background understanding of why you're doing it. It's to help you remember, but yeah.
Okay.
No bother. Okay, so that's the variation. It's not a lot of I suppose a lot of folk struggle with it because of the maths side of it. But I think the likes of Harvey's describe it in a very tangible way. You can visualize the clock ticking, and that every year, that minute or hour is passing by, and therefore it's confusing to people because the rate of change changes, and then the year, and then the combination of that, and so on. And people are on different maps, it can throw people a little bit. But it's quite a tangible. I think we've lost signal, perhaps you're all frozen. Just wait a second. If you can still hear me, it should come back.
I can still hear you.
Oh, perfect. It was just me, it's my end that's playing games. So yeah, so you can see, trying to teach someone that there is a benefit to not mentioning it until after people have got an understanding of what a bearing means, and how to do a guesstimate, and how to measure one, and then to add that extra little bit, and to lay the seed of them being different norths before you kind of launch straight into. A lot of folk have tried bearings. I think it's this magical way of finding their way and never getting lost again in the mountains. But obviously you need to, we took bearings over cliffs there. You need to read the map and understand the features to pick a bearing that's safe to travel along as well. And like that, if you've taken the bearing accurately, but you're not where you think you are, you'll still walk on that parallel line to where you thought you were, but you may not be where you were. So you're just walking a line that is 90 degrees. And if you're starting in point A, you'll end up at point B. But if you're starting somewhere else, you'll end up that angle from there instead, parallel to it. So things when you're walking on a bearing, like you're all in your houses at the moment. So if you set your compass to put on a bearing of say 120, and I'm doing that just because it points at my computer screen. So I've turned my dial to 120, and now the needle in the compass that floats, that I don't control, I'm going to move my compass until I'm going to just hold it into the center of my chest, flat on my hand. And I'm just going to move my shoulders until the magnetic needle sits exactly in that red needle that we were using on our maps, the dial that we turned. So the magnetic north sits on the compass's north. That makes sense.
Yeah.
I can't really lift it up here because gravity has an effect. So I'm sitting my magnetic needle in this north.
Yeah.
I'm doing it on a flat base, making a T junction with my chest and my shoulders. And I'm going to look straight down onto my compass. And I'm going to turn my shoulders until it sits exactly in it. And then I'm going to look up and pick out my windowsill, the hedge outside my house, the roof of the house across the road as my markers that are on my bearing. And then I'm going to put down the compass and I'm going to walk to the windowsill, the hedge, the house. I'm going to join those dots. And I can't see past the house, so then I'd have to take my bearing again once I get to that point. That makes sense. So you can all do that with your compass in your house now. Just stand up and orientate it. See where you've been walking. I'll know if I'm facing the same direction as any of you. Okay, and they've all gone. They've all set off on their bearings. Fantastic.
Halfway up the mountain by now.
Marvelous. You'll all be chomping at the bit now to get out and use it if you've not used it before. But no, it's great because you don't have to wait until the weather's really bad to try it out, obviously. And if you kind of even pulling it back to very simple terms in terms of setting the map, I would always try and keep my compass out and handy, so I'm more inclined to use it like your calculator to check your guesstimates are right, as a backup. So if you've set your map and you're off walking up the hill and you think north is over there because that's the way you've set your map, and then you pull out the compass and it's pointing the other way, the alarm bell will ring. I've gotten disorientated here for some reason. I sat down for lunch or the cloud just dropped down and I thought it was that way, but it's actually this way. You can use it as a backup plan. Don't entirely rely on your compass. Read the land, do all those other things that you normally do. But if you've taken your bearing, you've used the right point A to B, you've measured it accurately, you've done your variation, then you should be able to trust your compass. In bad weather, it should be a good, useful confidence thing to have. And if you've sighted properly, which is what I've just described there, so line it in with the chest and square the shoulders, rather than this kind of thing. Because I can't see the needles lined up anymore. It's out of sight. So it needs to be in. And that I've no phones or bunches of keys in my pocket, because that'll pull the needle in a different direction. Anything metal. And we often carry sat-navs, phones, loads of stuff in our pockets to hand. So make a point of, I keep my compass, usually I attach it to my rucksack strap so that I can take off my pack, change jackets, because we're constantly changing and layering system when we're out in Ireland. It rains, it stops, it's hot, it's cold, and so on. But I fasten it onto my rucksack strap and leave it somewhere, in one of the straps handy. but I would not carry my phones. I'd have them in the bottom of my rucksack, or if I really want it out, I'd have it in a leg pocket on the opposite side to the, I'm right-handed, so I put it in my left leg pocket, or somewhere low and out of the way for taking bearings. Poor guy on an assessment had it in his pocket. His girlfriend just rang him to wish him well on his assessment, and then he stuck it back in his chest pocket. And every single bearing, which is what he was coming back to be assessed particularly on, he'd get it right, measure it, and set off, and then off he'd go to the side, and he'd get somewhere he could navigate. So he knew it was wrong, but he could not understand what the problem was. And eventually we sussed it, and he did a leg, and he was bang on, so it was fine. Or he could have gone home never knowing why he was getting it wrong, Anna. It's going to annoy me to the grave. No, so picking your spot on the journey, putting down the compass, walking to that spot, and sighting again is far better. If it doesn't matter that you're dead accurate, you can just take a rough bearing and just set off and walk roughly in that direction. But you may veer downhill, you might veer uphill, the wind might blow you off course a bit. So if it's worth taking the bearing, then I definitely would be accurate with it. And the other way, if you're on top of, say, Lug na Quilla or Slieve-Berna or somewhere, and there's a safe route down the way you want to go, there's a nice broad ridge or spur that you can follow, that you're not going to fall off any cliffs, but you just get a glimpse in bad weather through the clouds to the car park or to the valley bottom or the track that you're heading for, a long way away, but on the route that you're going to travel. Take a bearing on it. And then you don't have to worry that you might drift off and go in the wrong direction. You just point your compass straight at the feature and line up this, the one that you can control, this arrow, with the magnetic needle that's showing, point it straight at your feature, and then just move this around until, I'm just going to move it to, it's no good because gravity is moving everything. Just join the two up. And you don't have to adjust anything. It's magnetic bearing that you're measuring. And that then will just keep pointing you in the right direction to go home, to go to the car park or get down to your track. As long as there's nothing dangerous on that route, the lake, the cliff, you'd have to go around. But it can be a great crutch, particularly in kind of winter, in bad weather where, there's maybe snow on the ground and you've not got that many visuals to sight on. Snow is white. That you've got that little opportunity to take advantage of the visibility that's there. So let me just check. We're kind of coming towards the end of all the content that we'd listed. If there are any questions, now's the time. Nope.
Jane, I was just wondering, at some stage, are you ever going to do, say, if you're going to do a particular route, and just to see how you do a route map, maybe?
Yeah, I can do. Yeah, route planning, is it? Yeah.
Yeah.
And when you say a route map, then you're maybe the duration, the time of it, how long you've got.
Well, maybe mostly the compass bearings.
Oh, a route card.
Yeah, route card.
Okay, no, I can do that. It's like, there are, again, any ideas for different versions of this are useful, and you guys should direct that, what's useful to you. So yeah. There is a presentation on route cards, which is on the website as well, on the training downloads. There's probably not a video on it because it's not really good video material. But it would involve your A to B, your grid references, which we know you're really good at, your bearing, your distance measurement, your timing, all pulled together to compile a card with all those bits of data on them. And things like that can be really useful to leave with someone else to know where you're going, your plan B, if something happens here, we might go down that way, and also for yourself on the hill to prepare your stuff. But with things like your distance and your bearing, I definitely double check them on the hill.
Yeah.
In your home, you don't have the visual clues that will say you've just done that backward. You're going to send yourself. Yeah. Do you know what I mean? So it's put it on and look, but I'd probably double check some of those measurements to make sure when you've got the visual on the hill. as
Yeah.
well. But yeah, that could be really useful. And you can share it with a few people on the hill. You can get other people to check bearings, you know, see if you
Yeah.
like we did today. And I made a mistake there. I wrote down the wrong number. I measured the right number and wrote down the wrong number. So those kind of things can happen easy enough. So it's good to double check things. But yeah, I think that's all of the topic bits that I wanted to cover. So you know where I am. There'll be an email will be sent out with all those links to the various resources on the website and videos and so forth. But you know where I am, sure, if you've any follow-up.
Yeah.
questions.
Lovely.
Okay,
Yeah.
great. Well, listen, enjoy. I hope you're going to get out now and go and
Thank you
practice
very
all of it.
much.
You're very welcome.
That was brilliant. And tomorrow's a good day.
Yes. Yep. All good. Take care. Nice to see you.
Okay.